So I'm doing the 8788 notes on cross sections. And these cross sections are just like cross sections you see on a slide in science class, microscopes. We're going to be finding the volumes of cross sections by doing integrals of the area of the whatever the base is, the cross section times dx. So this is the area of something times another dimension, the width of them. That's where the volume, the 3 dimensions come in. Okay, and there's 2 different kinds. There's the ones with x. I'm going to talk about these real quick. So if you're talking about perpendicular to the x-axis is the key wording here. It's going to say cross sections and perpendicular. This is a dx problem where everything's got to be in dx form, and then this is the left x value, and this is the right x value where the bounds are. Then sometimes it's going to say perpendicular to the y-axis, and again it's going to say cross-section. That tells you which formula we use from areas. And then this is, again, everything now is in terms of y. You have to have y's in all your stuff, and then this is the bottom y. The c is the bottom y, and the d is the top y value of this thing. Now, I hope you see over here this picture. These are cross sections that are semicircles, because if you take this thing right here and I were to draw across this way, this would be a semicircle, and I hope you know this whole thing here is a diameter. So you'd have to come in here to the midpoint to get the radius. We're going to use that in a little while. So hopefully you know the important information for squares. You got to know the length of a side, and because the area is side squared of that. And then for a rectangle, you need to know the length and the width. Some people call it base and height. That's fine too. But I'm going to write down length and width because the formula we normally do for a rectangle is area equals length times width, LW. And then a semicircle, the radius is the key, because the area of a regular old circle is pi r squared. But then this is half of that, so I'm going to put a half out front. And then a triangle, we got to know the base and the height. Okay, those are the key parts, because the area of an the area of a regular triangle is 1/2 base times height. I'm going to give you an equilateral triangle as well. There's a formula for it, even though you can find base and height of these, because when you draw the altitude in them, I'm going to show you real quick. This means all the angles are 60s, right? And all the sides are equal. And if you draw the altitude in here, this makes this a 30, 60, 90, and you're supposed to know how those sides relate. So whatever the hypotenuse is, well, the short leg's the key. Whatever the short leg is, you double for hypotenuse, and you take the short leg times radical 3 for the height of the rectangle. And then, of course, this whole base would be 2x, because we had to cut it in half for that part. But there is a formula for the area of an equilateral triangle. So the area of an equilateral triangle formula is radical 3 divided by 4 times one side squared. This was what you would get out of this, and I could show you how to do that. If you want me to in class, I will. All right, we're going to go ahead and do some examples here. So I'm going to graph these over here on this chart. So let's see, this is a y equals mx plus b chart. So my b is 1. I'm going to put red here because we're doing this one in red. And my slope is -0.5, so I'm going to go down 1/2. And I've already worked these out to make sure I can get them done quicker. And this thing keeps going like this and up here like this, but I don't really care, because the part I need is this part from there to there. And then I'm going to graph this other one in blue, the g of x, and its y-intercept's -1 from this, and its slope's +0.5, so I go up 1/2 here. And again, this is the part I need, and again, it keeps going in both directions, so I don't need that. And then this last one, x equals 0, so let's go black. X equals 0 is the y-axis, so again, this is the part I need right here, because this is the enclosed area I have right there. Okay, so the base of my object is this thing. Okay, so the first problem, key wording, cross section. So I know I got to find the area of an object. This tells me the area. So the area I need is side squared, because it's a square. And then the key to knowing which variables to use is I need x variables because perpendicular. So I'm going to have the integral, and it's the left place, which is 0 here, and they intersect over here at 2. So this is 0 to 2. And then I need to get a side of my square. Well, let's get a different color here. I don't know what color. I'll use purple. So the length of my square is this top to the bottom function. That's these two functions. That's the red one on top, blue on the bottom. So to get the length of your side, just like earlier we did the area between two curves, I'm going to take my top function, which is 1 minus x squared, x over 2, subtract it from my bottom function, which is negative 1 plus x over 2. And then this will be the length of the side of my square. So it's going to be 1 minus x over 2 plus 1 minus x over 2, which will end up being 1 plus 1 is 2. Negative a half and another negative half is negative 2 halves, which is negative x. That's the side of my square. So from top to bottom is 2 minus x. So the area of my square is a side from this formula squared, and we got dx. So when I solve this, this will be the volume. If I had a square coming like this, is like we're right above it looking straight down. So if I could bring a square towards us off the page and here and come up the same amount as this length here and go across, there'd be squares coming at us. So what you want to do here is you want to FOIL this thing. So we're going to get 0 to 2, 4 minus 2x plus x squared dx. And then we're going to do our integral steps. I'm going to add 1 to the power, put it underneath. I'm going to add 1 to the power, put it underneath. I'm going to add 1 to the power and put it underneath. And then we put this stuff in brackets. And we're going to do our lower bound, which is 0, or upper bound of 2. And I'm going to get this stuff out of the way. So this is going to equal, I got to stick my 2 in first. So my upper bound is 4 times 2 minus 2 squared plus 2 cubed over 3. And then minus my lower bound is 4 times 0 minus 0 squared plus 0 cubed divided by 3. I hope we see this whole side over here is 0. So over here I've got 8 minus 4 plus 8 thirds. Okay, so let's see, that's 4. Let's see, that's 4 plus 8 thirds. That's 2 and 2 thirds. So this whole thing is going to be 6 and 2 thirds. It's going to be my volume. Now, if you want to write that as 20 over 3, you can. So that would be the volume of the original problem. Okay, going on to the next problem. We're going to do the cross sections again of this problem. And once you find this thing, you're probably going to use this over and over again on these problems. But anyway, again, we got cross sections that are now semicircles. So the area of a semicircle is 1/2 pi r squared. So that's what I'm going to plug in where this thing went in for a side square. It's going to be a semicircle and perpendicular to the x-axis. So everything's dx again, but now I got semicircles coming up and coming across. So now this 2 minus x is no longer the side, that is the diameter. That's the diameter of my semicircle. So the radius on number 2 is going to be 2 minus x divided by 2, because you got to cut a diameter in half to get a radius. So this formula is going to be the integral, and it's still 0 to 2, because it's still all the way across there. We got all these semicircles going in there. And I'm going to take this half, and I'm going to stick it out front, because it's a coefficient. And then I got to take my, I'm also going to take my pi out there. So I'm going to stick my pi on top of that, because a half times pi is pi over 2. And then this is my radius, so I have to square my radius. Okay, so I'm going to square this thing. So I'm going to have pi over 2 again, integral 0 to 2. And when I square that top part, that's the same as this part. So on top, I got 4 minus 2x. Oops, I made a mistake right here. I just saw it. It's 2 times negative 1 times 2. This should have been a 4. Okay, Okay, so that makes this a 4, so this actually is a 2x squared. So I actually need a 2 in front of this, which is actually going to make this 8, which makes my math easier. So sorry I screwed that up. I'm just glad I caught it. So these two 8's cancel out, so it's minus that 0 from that. So this whole thing equals 8/3 up here. So the volume of the first one is 8/3. Luckily I caught that, or all these would have probably been wrong. But anyway, so this should be 4 minus 4x plus x squared. And then you square that 2 on the bottom, and that's a 4 dx. So now you want to take that 4 out in front because that's another coefficient. So we're going to get pi over 8, and then the integral from 0 to 2, and then all this stuff is the same. It's the same as what we just did up here, right? This thing right here. So what that means is this part from the integral 0 to 2 of all this, it is also 8/3. So this one is going to be the pi over 8 times 8/3 that we got from 1, because again, all of this is exactly the same from here across. So this whole thing is going to be a volume of pi/3 cubic, whatever the measurements are, cubic units. So that would be the semicircles. Now we're going to have rectangles. And it says the height's 3, so the area of this is going to be length times width, base times height, don't really care. But it's going to be, in other words, the height of all these coming off the screen are up 3 units, so it's going to be a base of 3, or a height of 3, sorry. And then my base is from top to bottom again, which is still this 2 minus x. So my area is 3 times 2 minus x for the rectangles. And we are still perpendicular to the x-axis and their cross section. So again, we're going to do the integral. I'm going to move that 3 out to front because this 3 right here is a coefficient, and it's going to be of 0 to 2. And then I've got my base in here is 2 minus x. Now this one is not squared because it's length times width, base times height, however you want to think about it, whatever you want to use. And we got this deal here. So this is going to be a little different answer. So I still got my 3, and then I'm going to do the integral of that 2 is 2x. The integral of x is x squared over 2. And we're doing our lower and upper bound is still 0 to 2 because it's from this 0 over to this 2 in this shaded area. Plug 2 in, and I'm going to get 4 minus, and 2 in there is 2 squared. Is 4 over 2 is 2. And you know what? I left my 3 off, so I got to have this 3 out front still. That 3 that's in front here. And then it's minus, and actually, take that off and put minus, and this part's going to go in parentheses because I got to distribute that 3 to everything. And 2 times 0 is 0, and 0 divided by 2 is 0. So this whole thing is going to be 4 minus 2 minus 0. So that's 2 times 3. This area is, or volume, not area, it is 6. So that is the third one. I'm going to keep going here, get this done, and then we'll see what's happening. Okay, now I just gave you, this is equilateral triangles. We're still perpendicular to the x-axis with cross sections, and I gave you the formula, which you can find it the other way, and if you want me to show it to you, I can. It's this. Well, I don't know if you remember, but way up here, in other words, this is one side of the equilateral triangle, and now it's coming up at us as an equilateral triangle here, not a semicircle. So the side on this one is, again, 2 minus x. So this s is 2 minus x, and everything else is the same. So I'm going to have, now this radical 3 over 4 is going to be my coefficient, so I'm going to move that in front of the radical. Integral 0 to 2, and then it's going to be s squared. Now my s is still the s from up top. It's still that 2 minus x I got up there, the top minus the bottom squared, dx. Now I hope you see that this right here is exactly what we had right here again. So all of this thing right here, all these steps are identical, and I already know that part is 8/3. So to make my videos a little quicker, this part's 8/3. We already found this part. And then my coefficient was radical 3 over 4 on this, so these reduce. So this answer would be 2, and this is the volume, 2 radical 3 all over 3. So this right here would be the volume of an equilateral triangle up there in that shaded part. You might want to Google cross sections so you can see them better. Oh my gosh! In my classroom, my camera is dying, but it's not dead yet. All right, so this problem, I gotta get over here where I can read it. The volume of a solid in which the base is a circle with radius 3. So what that means is this is the center of my circle. I go out 1, 2, 3. I hope that's on a line because I can't really see the graph because it's so dark. And I'm going to go over here to -3 and up to 3 and down to -3. And I don't know, again, I can't see the circle because my camera is, not my camera, but the bulb in my deal is slowly dying. So I got a circle like that. So this is the base right here. Oops, button. So this part's the part that I'm going to build my cross sections on, and they're going to come off of this circle at me. Okay, so let's see. We want perpendicular. We're perpendicular to x still, and we want squares, and it's still cross section, so we want squares. So we are going to still use the formula because the area of a square is side squared. Now this was a little tricky because the side is still from this top half of the circle down here to the bottom half of the circle. So the way you get this formula, if you remember a circle, this circle's formula would be x squared plus y squared equals 9. So y squared would equal 9 minus x squared. So y would equal a positive and negative radical 9 minus x squared for this circle. Well, the top part's the positive. So if I took diameter across here and did the top part, that's the positive part. And the part coming across the bottom is this negative part because it's below the x-axis for y. That's where y is negative. So top minus bottom on this, the side of my square in this case is going to be positive 9 minus x squared minus top minus bottom, and then it would be minus a negative 9 minus x squared. And these two negatives make a positive, so that makes my side actually 2, because it's one of these plus another one of these, 2 radical 9 minus x squareds. Now that's my side, so now I'm going to come up here now. This left side, x value is -3. Over here, this right side is +3. So that's my integral part from -3 to 3. And now, this thing right here is my side, so before I take anything out front, I've got to square my side, and this whole thing's the side, so I've got to square this whole thing right here before I do an integral. Well, 2 squared is 4, so I can now move my 4 out front of the integral. And when I square a square root, the square and square root cancel out, so I've got this deal. And so this is going to be 4. And then I can do my integral of 9, which is 9x minus x cubed over 3, and do my lower bound to my top bound. Now I'm gonna do something here because this is symmetric to the y-axis. Or better yet, I'm going to do it the long way, and then I'm going to show you a shortcut. I'm going to use a shortcut from now on, and you're going to want to know this because he may put this on the test. So I'm going to have a 4 out front, and then I got to plug my positive 3 in, which is 9 times 3 minus 3 cubed over 3. And the 3 is the only thing cubed here. Minus, I got 9 times negative 3. And then I got minus negative 3 cubed all over 3 by plugging in the lower bound. Okay? So over here, I've got this 4 still, and then I've got 27 minus 27 thirds, minus, and then I got negative 27, and then I got minus a negative 27 thirds. Okay, so I hope I don't need that bracket anymore. So then I got 2 negatives here, which makes this positive. And then when I distribute this negative in, probably should go ahead and reduce this to 9, right? Reduce this to 9. And then when I distribute my negative in there, this becomes plus, plus, and minus. So do you see that I got a 27? Oh, I do need a bracket out here because that 4 is times everything. So I got 4, and then I got two 27s. That's 54. I got two -9s. That's minus 18. Well, 54 minus 20 is 34, so that would be 36. So I got 4 times 36, which I believe 4 carry 2 is 144. So the volume of all these squares coming off the circle, coming at us and back across and back down to this side, would be 144. Now I want to show you something that's even faster than this, because if I were to cut this right, this is called an even function. If I cut this right down the middle and did the volume on the right side, the volume on the right and the left would be equal. So there's a shortcut on doing this, which makes your math easier. You can change that to a 0, and since there's 2 of them, you take this front part times 2, because there's the right side of the y-axis and the left side that are the same. And if you change this to an 8, and you take all these become 0 because you're plugging in 0 instead of the 3. So this whole thing becomes 0. So all of this is gone. This is all 0 here. And now this is 8. Okay. If I take 27 minus 9, 27 minus 9 is going to give me 18. If I take 8 times 18, I get 144. So by changing this to 0 and doubling the volume out here, or doubling the number out in front, I get the same answer, but my math is way easier because I don't have to calculate all those -3s. So that's a little trick to make this easier. So part 1, that is 144. Now I want to leave, I'm going to write up here 144 cubic, whatever the measurements are. I'm going to leave that up there, but I also want to leave my side over here, because this side is probably going to be used a whole bunch. Okay, so we're going to come here. Now this is the same as the other one. I think that says x-axis, but now we got semicircles, so the area is 1/2 pi r squared. Now like before, this is a side, that'd be the all the way across, but that'd be a diameter, so the radius would be half of this. So to get your radius, you got to divide this by 2, which makes these go away. So your r is just that part. Okay, so I'm going to write it down here. And then, oops, I want to get rid of that red stuff up there, so hold on a second. So when I divide this thing by 2, this is the diameter, and you divide that by 2, that makes the radius radical 9 minus x squared. So I'm going to plug that into this thing, and again, the pi over 2, the 1/2 times pi is your coefficient, and you're going to go from -3 to 3 because we're doing semicircles all the way across here, but I want to do my shortcut and go 0 to 3, which means I got to come out here and double this thing, because I'm doing half on the right of the y-axis is the part I'm getting, and then doubling it gives me that part. And that will save you all kinds of time. So we're going to take our radius, which is a square root of 9 minus x squared, and we're going to square that. And that cancels those out. So in the front, I've got a pi. Okay, and then I've got the integral from 0 to 2, and the square root cancel. So I got 9 minus x squared in here dx. Okay, and then I'm going to get leave my pi out front, and then I'm going to get 9x minus x cubed, come on, pen, x cubed over 3, and that's going to be from 0 to 3, and you plug the 3 in up there, and you get 27 minus 9. Now, if you remember, we had that a minute ago, but I erased it all, so we could have used this 18 again, and if you plug the zeros in here and here, you get 0, so maybe I should probably put minus the 0 from that. So this whole volume is going to be 18 pi for that. So if you notice, if I wouldn't have erased all that, we would have already known that I got 18 from this part without the 4. This part in here was without the 4. Okay? All right, we're going to do the same thing. Now we got equilateral triangles. So I'm going to erase this, but I'm going to remind myself that this part right here is 18, because it might help me out again without having to do all the math again. We're still perpendicular to S, equilateral triangles, so this is the formula radical 3 over 4s squared. Well, S is this whole side again, so that is this same, this is, again, this thing where the diameter was. Now this is the side of the equilateral triangle again, this part. Not the radius, not half of it, but the whole thing. Okay, so I'm going to get my radical 3 over 4. I'm going to do my integral, but I want to go 0 to 3 again, so I got to double this number out here because I need to get on both sides of the y-axis. And I'm going to take my side, which is 2 times the square root of 9 minus x squared, and I'm going to square that dx. Okay, so I go ahead and reduce this 2 and this 4 to 2 here, so I'm in front, I got a radical 3 over 2. I'm going to leave this 0 to 3, and then I got to square these two parts. So squaring out is a 4, and squaring a square root brings that part out. Then I'm going to bring this 4 out front, so that 2 and 4 will reduce the front part to 2 radical 3. And then I got the integral from 0 to 3 of 9 minus x squared dx. And this is where writing down up here, oops, I erased it, it looks like. We had 18 in here, if you remember. 27 minus 9, this part in here was 18. You see this is the same thing that this one is. The integral 0 to 2 without the pi. So the only difference is this pi is becoming 2 radical 3. So this is going to be 2 radical 3 times 18 again. So this answer would end up being 16 radical 3. That'd be the volume for the equilateral triangles. Again, this part is 18, okay? All right, we're going to do the last, maybe it's not the last one, there's one under, now that I'm remembering. Yes, there's another one. So we're going to do this next one, and this says still to the x-axis, but this says, what does this say? X-axis. Isosceles right triangle whose hypotenuse is on the base. So now you've got a hypotenuse of an isosceles right triangle. So the isosceles right triangle is coming off of the graph, and this side and this side are equal. So we got to have a flashback here. Now notice it is isosceles right triangle. So I'm going to turn that thing sideways. We're going to look at this, and this thing right here is my right angle at the top. That right angle at the top up here in the circle picture is this thing. And this base down here, this is the base of your right isosceles triangle. This is 2, and the radical 9 minus x squared. That's from the top to the bottom, that blue part, which is still this thing. Okay? So what I got to do is, that's my base. I need to find, actually, I want to find both of these, I believe. So I want to find both of those lengths. So I'm going to call these two lengths A. I don't really know what they are. I'm going to call this A, and I'm going to call this A. So now I can get that A squared plus A squared is going to equal hypotenuse squared. So 2A squared is going to equal 4 times 9 minus x squared when I square that thing. Then I'm going to divide by 2. I'm going to divide by 2 and get that A squared is going to equal, when I divide 4 by 2, I get 2 times 9 minus x squared. Now, if you want, you can square root this. I'm going to write it in here and just say this part down here goes in here. But isn't this a triangle where there's the height and there's the base because it's the right angle part? So I'm going to call this the height and this the base to get that area. So my area of this triangle is still going to be 1/2 base times height of this triangle, which in this case, both of these are A, so this is going to be 1/2 A squared from these little A's I stuck on here. And isn't this part right here A squared? I got my A squared right here. So I'm going to come over here and do my integral. And I'm not going to go 0 to, or negative 3 to 3. I'm going to do 0 to 3 again and double it. And then I got that half. This half right here that I put in front, and then A squared is this 2 times 9 minus x squared dx. these reduce to 1. I'm going to bring that 2 out front and do my integral of 9 minus x squared. So that'd be 9x. Well, I tell you what, I'm just going to write it down again. So this is integral 0 to 3 of 9 minus x squared dx. Now, if you remember, we've done that here, we did that here, we're doing it again here. That means it's the same value, which is 18. So this answer should be 36 for the volume. Again, if you want to practice integrals, go ahead and do that, but there's ways to make it a little faster. Last problem. The cross-section perpendicular, we're still to the x-axis, is isosceles right triangles with a leg resulting along the base. Okay, so how is that different? Well, it's different because it will look like, I'm going to erase this and it's going to get rid of some of my shadow and all that good stuff. But now, this is one of the legs, so this piece is coming straight up off the table at me, and it's going across like this, and this is my right angle that's coming off, but this is right at me. It should be right above this line, but you can't really tell that way. So the difference of this is, I'm going to make that blue again. So this was my side, which is still, it is still this thing right here. That's still my side, but now that's the leg of the right triangle. And since that is an isosceles right triangle, the difference is the blue part is this part, and it's equal to that part going up. And then this is the hypotenuse. It's no longer the base. So now, this part right here is 2 times 9 minus x squared. That's that part going across the yellow part of that circle. But this part up here is the same thing because they're equal legs. And that's my base and my height of my right triangle. So again, because it's a right triangle, it's 1/2 base times height, but those are my two bases. So those two things are, I can take one of them and square it and get it faster. So this is going to be the integral. And I'm going to put that 1/2 out front. And I could say -3 to 3, but if I go 0, I can double it again for the very same reason I doubled them before. And I get this. And then base is this 2, and the height's this thing, so it's that thing squared. Okay, so it's 2 times the square root of 9 minus x squared squared. Okay, because that's my base times my height. There's 2 of them, so I multiply them together, and I got dx. So I'm going to square these two things. So when I'm going to reduce this part. So I got integral 0 to 3. I square 2 and get 4. I take this part out because it's in a square root and I'm squaring it. And I got this look. Then I'm going to move this 4 out in front from 0 to 3. Okay. And then I still have my 9 minus x squared dx again, which is that the same thing I've had on almost every problem, which we found earlier that became 18 right there. So this is still 18. So this is going to be 4 times 18, which is 40, and 32 is 72 is the volume of this last one. So this stuff is kind of difficult, but you need to practice it. And I will see you guys next class.